still into this chapter. So let's just look at this. They say we want to talk about how we produce messages to Kafka. A lot of details, but just let's go through step by step. We'll talk about key-based partitioning. We'll talk about the difference in acknowledgements. We'll talk about delivery timeouts. And then we'll talk about producer properties and just a lot of really interesting concepts. So we want to look at first of all, we start by looking at the default clients that we have in Kafka. Now, Java and Scala, oh, by the way, just to let you guys know, who can guess what language Kafka is written in?
Go.
I'm sorry? Scala. So Scala, but we have a lot of Java clients. And of course, there's a lot to do with the Java API for original. If you look at the broker software, you guys will see that Scala, but of course, lots of Java clients, and a lot of these are native clients. And I think there was a question, sorry. Brett, did you have a question or someone else? Oh, okay, my mistake. So we have a lot of the native clients that you can use. If you are not using the default ones, for example, Java, Scala, and you want to use something like C, C++, Go, .NET, that's okay, because all of these clients use an underlying library called librd Kafka. It's a C library, and it's very fast. And then we have a lot of documentation on our site. So basically, if you are a front-end developer and you're writing programs in Kotlin or Java, or using, maybe you're doing front-end and back-end using Node.js, whatever language you choose, all of those clients use this underlying library. Yeah, but Java and Scala these are the default, what they call the first-class citizen, right? But all of these other clients, right, you can use. And again, very fast. So when you talk about the client library, this librd Kafka, it is actually super fast. So even if you're writing producers and you're using Python, well, your Python code is going to be fast because of this library, right? Underneath the hood, you call this library. And this is very important, okay? So just to know that. Now, this is a little bit different from using a REST API. So remember, I can write producer or consumer using any one of these languages because it uses the underlying library. But if I write, let's say, a Python program, and I send messages, make HTTP calls to the REST proxy, and the REST proxy is the one that then creates the producer or consumer that works with the Kafka cluster. So I'll just put your Kafka. In this situation, I can use any programming language as long as the language can make HTTP calls to the REST proxy. The REST proxy is the one that will create the producer or consumer. And we'll see this in a later picture. But this is different. This is not the same as using the lib. So there's the different way to produce. If you're using a REST proxy, you're basically using some programming language to make HTTP calls to the REST proxy service, which then creates the producer if you're doing post, or it creates the consumer if you're doing a get to work on Kafka. But we'll come back to these things. So for now, just know that you can basically write your program in almost any language. Okay, lots of flexibility to work with Kafka. Use whatever language you want that is supported, and then write your producers to produce data to Kafka. And if you don't want to produce directly to the brokers, you can send it through the REST proxy, make HTTP calls. Any programming language that can make HTTP call to the REST proxy can produce to Kafka. Now, this picture shows the Kafka producer. So there's a Kafka producer in the API. And when you write your producer code, at some point, you will say producer.send somewhere in your code. At the end, we'll see this coming up in just a second. Producer.send. Okay. And when you say send, to send the data to Kafka, to some topic, you'll see that your data will then go through a process of serialization. Because remember, the broker only stores bytes, right? Only ones and zeros, bytes. So it goes through a serialization, then there's a partitioning phase. And then there's another phase called batching, right? So it goes through serialization, partitioning, then batching. You put all the data that is going together to a certain partition gets batched together. And then you batch per partition first, and then per broker, the broker that the data needs to go to, right? And then this is going over the network at this point. There's a separate background thread that will pull this. All of this part right here is happening on your producer code. In your producer code, all of this here is producer side, right? And then once you're ready, there will be all of this information ready to be sent across the network. There'll be a separate background thread that will pull this information and then send that information over the network. And then that information will then go to the Kafka cluster. This is showing the Kafka cluster here, but imagine that this is now going to the brokers. So the information will go to the Kafka cluster. And people can, sometimes they have a load balancer in front so that you can connect to the load balancer, which then distributes your information, where you need to go in the cluster. So it depends how you set it up in your environment, but just know that this is now going to your Kafka cluster when you send. So when you serialize, you partition, then you batch, and then this producer, you are the producer sending this data to your Kafka cluster. You need to get that probably in acknowledgement, and we'll see this whether you want an acknowledgement or not. But if it's successful, right, you can get back a metadata, success return. And if it's not successful and you have retries, what they call retries enable, that means if I'm a producer application, my job is to send the data to, let's say pretend that you guys are the brokers. So I'm a producer, I'm sending the data, When I send, okay, here comes X. And if I don't care that you receive this X, I don't care. Maybe I'll just say, okay, here comes Y. Okay, here comes A. Here comes B. I'm sending it to you. But if I want you to basically acknowledge me, I would say, okay, I want acknowledgement when I send this Y or X, acknowledge that you've received it. And we will talk about this in more detail. But the whole point is, I don't have to know every broker. I just have to be able to connect to one of those brokers, and I will always be able to get back a metadata reply that would tell me where all the partitions are in the cluster, where the partitions live, what topic and what partitions, all the partitions of the topic. So I will know all that information. And then I can always use a callback, and we'll talk more about callbacks a little bit later. But here's your producer record. You have information about the topic, the partition, timestamp. But typically, I don't have to get to that level of granularity. I can just say, hey, I want to produce to this topic called RoboTop. The topic name is Robo, and here's the data. And I just send it to the Robo topic. And then Kafka would take care of all the stuff underneath. Okay, so we will see this picture. Again, this is not the end here. Gang says, if the topic has 15 partitions and assuming there's only this consumer in their group, it will have 15 processes. Now that one consumer will be the one to read from those 15 partitions. That one consumer, it will still access those partitions in parallel. It's not going to go to one partition and then the next, and then the next, and then the next. So it will access those partitions in parallel to get the information. Yeah, awesome. And on that same question, which is really interesting, is just like you said, if I have 15 partitions, right? It's like saying, imagine I have a stack of data this much. Think of it as a building, and there's 15 floors. 15 floors in this building, right? And imagine that you are a janitor. If you have to clean all the floors by yourself, yep, you'll clean, and you can go to any floor at any time, but you are the only person that can clean all the floors. So that's a lot of work for you. And this is just like one consumer in a group, but if you scale, imagine there's 15 janitors, but in this case, we'll call them consumers. If you put 15 people, go, okay, each person take a floor. Whoop. Each person takes one floor. Then guess what? You will be finished about 15 times faster, right? Literally. So when we look at partition, when we look at consumers in consumer groups later on, we're not talking about consumers right now, but that would be a very important point to understand. But this picture for now, all I can say is this. In this picture, just know that when you create your producer, when your producer code, at some point you will say send. And when you do send, you go through serialization. Then you partition to figure out what partition the data needs to go to. It will use the key, and we'll see that coming up in just a second. And then you will end up building batches. Now, here's a question for you guys. What if there's only one record? If I only have one record to send, is it still a batch? It's sort of a tricky question. You build batches, but if you have zero latency and one record is there, then the record itself has a record header, and the message header itself there's a message header, there's a record header. So it's like a batch of one, but it's still just one message in there, and it goes across the network. But if I wait a little bit to accumulate more messages, I can batch a lot of records together, and we'll look at these processes coming up. So in Kafka, you go through serialization, partition, and then you batch. But let's go on to this. Now, they said, well, when we're talking about partitioning, what are we doing at this point? We're doing partitioning. Well, we have to figure out what partition the data is going to go to. So this is a question that all beginners have, right? If I have brokers in Kafka cluster, here's a broker, here's a broker, here's another broker, and this topic called robo has 3 partitions, and here's P0 partition 0, and this is partition 1, and let's say partition 2. Well, I have a record to be sent, and this is, let's say, robot. There's a robot with the ID and an IQ, let's say. And then the robot has a lot of information, the density, the cost, the color, or whatever it is. But let's say this is the key. So you'll do a hash of this key, and then modulo number of partitions, but number of partitions in this case is 3. There's 3 partitions in this robo topic. So you hash of key modulo 3. So the first time your answer may go to 0. First, the next robo key that you get with whatever 2000 ID, that may go to 1. And the next time you get a different one, it may go to 2. So there will always be a 0, 1, and 2 when you do your results of this formula right here. It will always go to either 0 or to 1 or to 2, right? And if it goes to 0, that means when you build your batch, that batch will come to this broker 1 because this broker 1 has partition 0. And if it needs to go to 1, all messages going to 1 will go to this broker here, broker 2. All messages going to 2 will go to this broker here, right? So even though you're producing lots of records, you could have gigabytes or terabytes of messages coming in, but each individual message will go through this process, do a hash of the key, module number of partitions to figure out where to go. Okay, any questions about that? This is typically one of the biggest questions. People always say, well, how does Kafka know where to send the message? Well, every message does a hash of the key. Then you say, well, what if I don't use a key? That's a good question. If you don't use a key, how do I know the message is going to come to this, this, or this? Well, then Kafka does it on like a round robin, or you could say random. It randomly just throws it across to the different partitions. So when you're writing your producer, you either use a key, or if you have no key, then think of it as round robin. If you have a key, then follow this formula, hash of the key. So from a producer, it's just, hey, you're not using a key. That means I have a record. Imagine like a sentence or entire sentence. I just want to produce the sentence to Kafka. Okay, I'm not specifying the key. I could specify a key, but I'm not. Then send that record. First it will go here. The next record will go here. Next record will go here. Each one will go one. Okay. Any questions about that before I continue? You guys okay? I'm looking into chat. Okay, thank you. I will look for at least one, and I require at least x equals to 1. Maybe some of you got it, maybe you don't, but you will understand that soon. X equals 1 is how I operate a little bit. Okay. So with that, let me ask you a question. Look at this orange. You notice that all the orange color will go to the same partition. All the purple go into the same partition. All the kind of like bluish or this color go into the same partition, teal, right? So if the key, whenever this key occurs, if it goes to partition 0 the first time, it's always going to go to partition 0 because the hash will never change, right? So if it goes to one partition, it will always go to the same partition, okay? And this is important for you to be aware of. So let's say partition is important to consider for if you want to do aggregations and joins when you're doing stream processing, or if you want to make sure that the message ordering, like for a given key, it's on a per key basis, or if you're dealing with large quantities of data, let's say across many brokers, or if you're scaling downstream consumer processing, a lot of different reasons that you want to be able to make sure you're comfortable with this, right? And if you remember, if there's no key, then it's just round robin across Kafka. Yeah. Yeah, that's good enough for now. Let's go on to this one. So now I want to send the messages to the brokers. And I say, okay, at this point, how do I'm a producer. I only have to understand how to contact the brokers, right? So there's a property called bootstrap servers, and it's an easy way to remember this. You see, in the old days, I think only one person may be familiar with that, the guy from Novell, I forget who it was, but in the old days, we had clients who needed to join a network, and the client didn't have any information about themselves. So they needed to be able to do what's called a bootstrap. They'll bootstrap themselves to be able to get like a IP address or something like that. And so this bootstrap concept comes from the old days. So in Kafka, here you are, you're a client. You don't know where your topic lives or anything, but you're just going to contact one of these brokers to get bootstrapped. In other words, to get the information you need to be able to contact these brokers. So this property is called bootstrap.servers. It's an easy way to remember. Okay, helps you, bootstrap yourself into this environment so you can you'll be able to contact one of the brokers. You always specify a list of brokers, like comma separate a list of brokers and port number. So if I have 3 brokers like this, so even if I have 20 brokers, I won't put all 20. I only need about 3 for redundancy, right? I don't need more than 3. And then a question says, I wonder what this key is referring to. Key is in key value pair key or something like the one in the lab. Property phase parse the key. Yes. Okay. Thank you for asking the question, Eric. Now, in a lab that you guys did, if you remember, first you wrote some data, whatever you wrote, you had like some data, and it could be anything, right? It could be, hello, Joe. But you didn't tell Kafka that you wanted to use a key. So Kafka sent this to, you produced that to the broker. So when you went to look at it, it showed you the results. When you consume that data, it showed you null, because you were not using a key, right? So that's the first thing, because when you first produced the data, the first time you used a producer, all you did was type some data, whatever you type, and then you type Control D. So it's like, this is a record that was sent to Kafka. This is a record, but you didn't say that you want to use a key. So the key end up null. But the second time you said, hey, wait a second, here's the data I'm writing, and I'm just going to make this up. Let's say I have robot X : and I have the cost 9 million, and I have the density 5.99, whatever. I have location in New York City. Anyway, every robot, this is robot X, robot Y, robot Z. There's millions of records with different robots. But now I say, okay, look, here's a colon. I say, look, this is going to separate my key from my value. So I'm saying use this to be the key. This is the key separator right here. I mean, the separator from key and value. All of this is the value. So every record, this is one record I'm producing, and a colon. In your exercise, you had like whatever data here, and I forget what the key was, but you have this part. The important thing is you said, look, I'm using this as the separator so that this is the key and this is the value. And so then when you go ahead and you parse, you set that parse key, when you print out the results, then it shows you, okay, instead of saying a null like this, you actually see the key, like whatever the key was, whatever the key was, and then you see the value, the record, whatever the data was on the side. So because now you have, so if I have an entire line that says, for example, zip code 90310, and then I have a whole bunch of information, like this is all the prices of homes in this zip code, 9, 10, 11, and maybe addresses, and also some other information. I can always select this column, say, okay, I want this to be my key. This column, the data in this column would be my key, and the rest of this will be my value. So Kafka, in other words, understands this. So another question says, it can be used to split the massive parallel. Yeah, so when you're working with key value pairs, it's very powerful in processing, working with distributed systems. And like I said before, coming from the Hadoop world, this is what MapReduce introduced to the world, to be able to process key value pairs and work with them. So it's just like distributed hashes as well, very powerful in programming world. But they say, I wonder what the key, so that's what the key, hopefully that helps you with the key, understand the key part. And then Shilin says, a good example of key is user ID, driver ID. Yes, so perfect, if you're dealing with user information and you have a user ID, you can use the user ID as the key, and then all the information about the user as the value, right? Think of a user profile, right? That's another example. And then also, this is another comment. If you want to count the total purchase of users, you can partition a message by using key or user ID. And yeah, absolutely. Okay. And we're built on this step by step, but for now, just know that hopefully that clarifies the concept in the lab as to why we did that parse key. We said we want to use a key, and then we specified what the key was going to be. And then as the output, you got the key and the value, because you specify what the key separator. Okay. Yes, we're still talking about key value. So whenever you're when you're producing records to Kafka, if you don't specify a key, then it's like the first exercise you did where you're writing the data, but you're not specifying a key. So essentially, it will be sent in a different way. But if you do specify a key, then Kafka does a hash of the key instead of the hash of the key modulo number of partitions. You're welcome. No, that's good. Okay, so in this case, the producer now needs to be able to produce the record to the broker. So your producer needs to know this bootstrap server's property, which is very important. The producer also has this concept, there's a key serializer. Let's come back to this. So there's a serializer and a value serializer. So the serializer is the class used to serialize the key, right? Must implement Kafka. We'll talk more about this a little bit later. And then the value serializer, right? Must implement the Kafka serializer interface as well. So key and value serializers, this is very important. The key serializer must be specified. So even if you don't use key, you still have to have this in your code. So there's a few things in Kafka that you have to understand a little bit more, but you must have the key serializer even if you're not using keys. And then compression type. Now, let's say you have large messages. Well, think about it. If I give you a large file if I give each of you a large file and I say copy it to your neighbor, you know that you're going to saturate your network real quickly because the data is large. But if you compress the data, right? If you compress the data, then of course you get better performance. So compression, all I can tell you here is it's a trade-off. Compression. There's a trade-off is time and space, right? So some algorithms does a better job of compressing, and some does do it a lot faster. So, for example, if you use Snappy, Snappy was created by Google, right? Snappy is very fast, so it doesn't take that much time. You have less time, but Snappy does not compress as well as gzip. So, for example, you take more space than gzip will be. Whereas if you're using gzip, gzip takes a longer time, so the time is more, but the space is less. It uses less space. So there's a trade-off in when you are thinking about compression. Compression always helps the performance in your environment, but the trade-off is time and space. What do you want? So in the big data world, when we would think about it, we say, hey, if this is hot data we need to access and be able to, decompress right away, then something like Snappy was very, very handy, very, very fast because the space didn't really matter. But if space and keeping the message smaller is more important, then you want to go with a better compression utility like gzip. As long as you understand that, to make it work in Kafka is very simple. You just have to specify the property, just a compression.type, and then you specify what type you want, right? You're compressed to do it, it's compressed on the producer side, and then it will be stored in that compressed format on the broker, and then the consumer will decompress it, right? So this is important to understand. And then let's go on to now, acknowledgement. The acknowledgements here are really important. Now, when you write your producer, this is still on the producer side. Everything we're talking about so far is the producer application. That means in your producer code, you get to determine the whether you want to have acknowledgement of your records or not. Okay, so this is important. As a producer, here I'm a producer. I'm sending a request. It's sort of awkward for people to think about sometimes because it is a producer request. Why is it, why is it a producer request? Because I'm asking the brokers, I say, hey, brokers, can you store this data for me? Because the broker needs to be able to store it in its log, right? So it's a producer request to the broker to say, please store my data. Now, I want to know if the broker stored it. So if I say, all I care about is for the leader to let me know that it's received the data, then I want to set that to AX equals 1. That means only the leader needs to respond to me and say, hey, Hussein, I got it. I got your request and I'm storing it for you. Then I'm going, yes, I'm happy. Only the leader. But we know there's always a leader and there's always 2 followers, right? Because in production, now, of course, this is if you have replication factor equals 3. And in production, that's the recommended way to go. Replication factor equals 3 is recommended for production. You can change it if you want, but this is what most customers go with. That means I'll always have 1 leader and 2 followers. So in this case, I'm saying, look, only the leader is required. But if I say X equals all or -1, I'm saying I want the leader to respond, but I want the follower as well to acknowledge. Followers as well should acknowledge. Okay? That's the X equals all. All of the in-sync, all of these brokers need to respond. And then the last one is 0 saying, hey, I don't require any response. It's like UDP, right? In the networking world. You fire and forget, right? Fire and forget. That means I can just send. I do not require any acknowledgement. So when you say X equals 0, this is what it's used for. You just send. Now, some people say, well, if there's no acknowledgement, does that mean I lose my data? No. Remember, we are looking at edge cases to say, look, we want to make sure that the broker lets us know that it has the data, but it doesn't mean that the data will be lost. But if we require acknowledgement and we don't get back the acknowledgement, then we will retry. We'll retry to send the data again. We'll retry. But if I say X equals 0, which says, hey, you don't have to answer me. If I say, are you okay? You don't have to answer me. Then I don't need to ask the question, are you okay? I just continue to lecture all night without asking you a single question. That's like X equals 0. Then I'm making an assumption. It does not mean that you don't understand it. It just means that whether you understand it or not, I'm just lecturing without asking you a question. And that's X equals 0. So I don't like X equals 0. So my previous joke that I made earlier, when I say, in this class, I would like to have at least X equals 1. That means someone has to respond. At least one, the leader must respond, in other words. But it would be much better if X equals all. and Schilling saying, Ack, thank you. See, that's at least one acknowledgement right there, and which means I can move on. But if everyone acknowledges, then we are good to go. Do you guys feel comfortable with this? This is something in your producer side. Before I move on, it's really important concept because you are controlling, to some extent, your durability of the messages. Now, remember, it does not mean that it will be lost. What it does mean is there's no guarantees, because if there's an edge case where they failed to write the message, commit the message, then that could be lost. But imagine if I'm capturing sensor data. I have temperature readings coming from sensors, and let's say it's every second or every minute, even if it's every minute, right? And I have sensor readings coming into my Kafka cluster, or every 10 seconds or so. And maybe at the end of every 5 minutes, I take the average temperature reading for that 5-minute period. Well, if I lose a couple of records, it's not a big deal, right? So X equals 0 will make it much faster because I don't have to wait. And even if I lose a few, no problem. Now, question from Lee says, as a producer, if I want to produce say 100 messages and set X equals 1, it will produce them one by one. No, actually, this is when you're writing with the producer, it's asynchronous. You can force it to be synchronous, but you can, it's asynchronous, right? So it will produce, it won't, so only when acknowledged, then it will get, yeah. So now you can have multiple messages in flight at the same time. And it's actually pretty interesting, but you will get your acknowledged messages, and this will happen really fast. And actually, it's sort of interesting because when you really look at it, Kafka enforces certain rules when you use what's called the idempotent producer, and it will make sure that the messages, even though you have multiple messages in flight at the same time, one will be, it will sort of, I mean, in a way, it does sort of acknowledge it before the next one, because it will be in the batch, and it will keep it in order and guarantee that those messages will be written in order from a single producer. So yeah, to some extent it would, but even though it's asynchronous. So what I said I would have to use if I ensure that the sequence of my Kafka events. We will get to some of those settings coming up in just a second. Not just a second, but a little bit later. In other words, there's like the idempotent producer that you have to set. You have to say enable idempotence and set it to true, and we'll see that. Yep. And we will, yes, we will definitely talk about that a little bit more. Okay. So hopefully, but so far, let's ask this question. Okay. How do you guys feel? Does it make sense when I say acts? Acts are set on the producer in the producer code. Everybody's okay with that, right? And in a production environment, we typically run with acts equals all. This is the recommended that most people will run with in production, okay? Or -1, correct, okay? So this is something to keep in mind. Perfect, guys. Let's go on to this now. So then you have some properties, and these are properties. I would say don't worry too much about this right now. We are going to come back to batch size. Very important properties here. And this delivery timeout. This puts an upper bound on the time to report success or failure after call to send, after returns. And you can use this to control the producer retries. The default is this. This is in milliseconds, right? So as a producer, your job is to send, right? If you can't send for some time, you'll end up buffering. And if you can't buffer, you then block. And then after some time, you throw an exception, right? But we'll talk about this in a little bit more detail. So the delivery timeout, you'll see that they say, look, hey, this is a very important process. We want to be able to control this and control how our messages are delivered to some extent. And this is, look, it puts an upper bound on this property, and you'll see this notes in your stuff too. And there's some detail in the API. But for now, just know that this is important to understand. And then this one, batch size and linger milliseconds, they are super important to understand because they say maximum number of bytes for a batch of message to send. The default is 16K right there. And then the time, how long you wait. And we'll talk about some really interesting things related to batch size and linger. There's some great labs that you will cover in this. These are very important properties. I'm going to talk about them in just a moment. It's coming up, but I just want to go to this page. We just saw this one with AX. So this is like a repeat of what we just saw, right? This is AX equals 1, where the leader, well, this is AX equals 0, sorry. So you do not get back, there's no acknowledgement required. When you say AX equals 1, then the leader needs to respond with an acknowledgement. When you say AX equals all or -1, then the followers also must respond. And that's what we just talked about. So we'll come back to this. And then this is the concept here of what's called in-sync replicas. And we sort of talked a little bit about it before. So if I have 3 brokers 101, 102, 103, right? They all need to be within a 30-second, all the followers need to be within 30-second lag time behind the leader. So as soon as this leader gets a record, assume that this is the message that it gets coming to the log. And the message is A right there. This follower has a job to do. It needs to fetch this A as quick as possible so that it can write it into its log A. And this one needs to do the same thing, fetch it as quick as possible so that it can write it into its log A. So in other words, it needs to be able to write it into its log as quick as possible, right? And this is what happens. If it doesn't do that within the 30-second period, it falls out of sync. So this is 101, 102, 103. If, let's say, 103 falls behind because it's too slow, maybe it's a network issue, maybe it's garbage collection, whatever it is, then that is no longer in sync, which means that the producers do not have to wait for this one. 103, we do not, if I have my AX equals all, it say wait for the leader and all the followers, right? But this follower is too slow, so I don't have to wait for it. So which means just these 2 will be okay. And there's another property we will see called the min in-sync replicas, like the minimum amount of replicas that need to be in the list before the producer can get the acknowledgement. So in other words, you typically set that in the production environment. The property is called min.insync.replicas. This is typically set to 2, right? So in production, we typically run with AX equals all, min in-sync replica set to 2. That means there must be at least 2 brokers that are in sync and then to answer their producer request, right? And so this is an important concept, very important concept. Let me know if you have any questions with that. Okay. Awesome. And by the way, if you guys find that you're understanding this very well, then what that means is this course also has a certification for it. And the certification is a developer cert, and you can take it. And if you pass it, you become Confluent certified Kafka developer. Then Martin says, oh, the 2 including the current leader? Yes, including leader. So when you see the in-sync replica list, there's always a list of leaders and followers. And so the leader is always included in the list. And if it falls out of sync, when I say min in sync, that means That's the number of brokers that must be alive and there to answer requests. And typically your leader will always be there because you're always communicating with the leader, right? Okay. So that's what this one is all about. And then now, this is what we were talking about before, the stuck follower. If the follower if it's slow for whatever reason, falls behind, right? For whatever reason, then this follower is now back, right? It's beyond this time, then this is a problem. Question.
Yes. So, Hussein, actually, I had a question. Sorry, I had to type before. Yeah, because if we do X equal to all, aren't we like unnecessarily increasing the communication between the brokers, kind of loading Kafka for no reason?
No, not really. It's still very fast from a producer perspective, and you're not really. I mean, you are increasing the time that you need to wait for those followers to respond because you need your acknowledgement. And this has been taken, but it's still super fast, millisecond performance. Now, 0, of course, is going to be faster than 1, and 1 is going to be faster than all. But Kafka is still pretty fast. So in production, although you are increasing the latency a little bit more, they've been over time been tested and proven. And so majority of the customer and everyone else knows that, yes, we need to run with the X equals all majority of the time. You'll see that. Let's see. I see some.
And actually, the communication between brokers are still there as long as you need replication. So this does not increase replication or increase any traffic between broker to broker. It's actually just waiting for the client waiting for you.
Correct. The communication that happens in Kafka is always when you have leaders and followers, it's always going on. I mean, there has been measurable to say, look, if I have a leader here, here's my leader, here's my follower, here's my follower. Yes, these followers, because you're waiting, I'm a producer, I send my data. I'm not just waiting for this leader, but I have to wait for these followers. Yes, so there's some latency there, but again, naturally, these systems, I mean, it's not so much like the zookeeper communicating. The brokers are always communicating with zookeepers and not so much inter-broker processes. There is some, but not as much as you see in other frameworks like between zookeepers or something like that. So yeah, I mean, good comments, and yeah, everything is right. Just as long as you know that X equals all is not a bad thing. Kafka is super fast. But if I'm doing like sensor kind of data where I'm capturing sensors or web logs where it's not that critical, I would go with 0 because it's going to be 0 is going to be faster. And because if I miss a few sensor readings, no big deal. I'm getting every 5 seconds, I'm getting a reading from a sensor, or maybe every second from a sensor. No problem. X equals 0 is what I would use for something like that. Now, the important thing for us to also understand is this. What does it mean by messages committed? Because we want the messages to be committed, right? The broker, we send a request to the broker, say, hey, broker, can you store this message, right? And then the broker needs to be able to store this message and let us know that, yeah, it has the message. But you'll see that this message is committed when the other brokers, the followers in the Kafka cluster has now requested, notice like here, notice how it's committed right there on this line, this message is committed here at 3. Okay, committed here. The leader, the follower now, what does that mean? It has this here also committed here in this log, but notice this one, for whatever reason, is stuck and slow and behind, so it does not have the message. So it's very important to understand that there's this concept of when you talk about this leader and follower, you talk about committed message. I mean, there's some details that we don't talk about here, but let me just mention it. When a producer sends a record to a broker, there's a broker 1, it's not really going to the disk right away, right? Because remember, I/O to the disk drive is pretty slow. So Kafka says, wait a second, I have memory in the system, like the physical memory chip you put in the system, memory, this memory, right? But there's a portion of mean memory. This is your mean memory in the system. And that portion of mean memory is what they call the page cache. P-A-G-E, page cache. So when you first send the data to the broker, the data is here in the page cache. Okay. And when a follower is fetching from, this is a follower, when it's fetching from the leader, it's actually fetching from this page cache and bringing it to its own page cache. And then at some point, the operating system will flush it to the disk. Follower, same thing. The operating system, the OS, will flush that to the disk at some point. All the followers are doing the same thing. They have their own page cache in memory, and they have to bring that data, get it from here, and bring it to their own system, and then they will flush it to the disk at some point. So you're actually dealing with memory, right? And it's very, very fast. So what does it mean by committed? These followers need to request, they need to let the leader know that they have their message. So if I have message 3, when I request the next higher message, when I request 4, this is when the leader knows that you have committed 3. Only, so if you ask me, for example, for 5, then I'll tell you. And then Sherwin says, high watermark is the highest offset that all Instagram has committed. High watermark advances beyond the offset. Yeah, so that's what they say. And this is important. So the it represents this concept, like they say, and this is in your notes as well, right? It tells you that the leader and the followers are identical up until this point. That's what that represents, right? So both leader and followers, they're identical up to this point, and that point is the high water mark, right? And so it's important to know what the high water mark is. That means they're all identical up until that point, but also to know what it means to be committed, right? So you commit the message. How do I know that the follower has committed this message? When the follower asks for the next higher message, then I know this, okay? And this is, and we'll talk about this one. How is the high water? This is something that the leader will set. In other words, it sets this after it. So the leader receives the message, and this leader will then say, hey, I'm now going to set it. And this, I mean, there's some underlying detail, but when I get the message, I can say, okay, I committed. And at some point, I need the followers to let me know that they can commit it. And then I will send them this, think of it as like a marker and say, okay, yeah, you are now up to this, okay? It's just something, yeah. So this is because we don't want the follower to keep on requesting. We will, when the follower requests or fetch the next higher offset and fetch null, then that leader will then send that information. And I said the leader will see the follower request, get next message parameter. Yeah, oh yeah. There's some level of detail that, yeah, you we're definitely some good information there. And just in the essence of, just want to make sure, because for now, as long as you guys understand the concept, I will show you a lot more detail. There's tons of detail in the API and documentation, but I want to make sure that you understand these concepts, and then we'll move on from there. But yes, the leader failure, again, this one is with the stuck follower. If the follower is stuck, right, as you can see in this picture, this case, we're saying, look, here's an in-sync follower in this follower here. So this leader dies, and here's this broker 102 is going to become the new leader, and this one is followed. So one, the leader dies, one is slow, and only one is in the list. One broker is in the list. So this you have to be careful with, because in this case, this is an in-sync replica of, I mean, this is the min in-sync replica. In other words, there's only one replica in the list, right? So you have to be careful with this, because if you have that property min in-sync replica set to 2 and you only have 1, then you have a problem. But you need to make sure that this isn't, these are edge cases. These are edge cases. And let's look at this one here. Let's say, when does x equals all equals the same as x equals 1? Well, in this case, if in my producer code, I say, hey, look at this. What do I have here? Oops. Sorry about that. In my producer code, I say, look, I have ax equals all, and I say I want the min in-sync replica set to 1. That means as long as one replica exists, I can get my acknowledgement, right? In this case, it's almost exactly like saying ax equals 1, because only one is going to answer. Okay, so this is important to understand that this is when, in other words, this is when the situation can occur where your ax equals, sorry, just there we go. So it's the same. Ax equals 1 is pretty much the same as this when you have this setting and the min in-sync replica set to 1. Okay, perfect. Let's go on to the next one. And then enforce the ax equals all. Now, if you look at this property, right? Let's say ax equals all, min in-sync replica set to 2. This is typically what we recommend in production, right? And just to know that this is, again, a situation, if you notice that I have the leader fill in this particular picture, right? And then now 102 becomes the new leader. And then this one is still stuck. There's still 1. And in this picture, we're saying, look, if you want to enforce it, then make sure you set this property to say, look, I want to have my min in-sync replica set to 2. Then what will happen is it will show that the producer raises an exception if majority of the replicas do not receive a write. So if it doesn't have those replicas there to be able to respond, then you can have an exception. So this is something that you can also handle. We'll see lots of detail here. And again, you see the source code to the API, but first, if you don't understand it at a very high level, it's going to be very difficult to move on with this. So let me know if you have any questions. And then this is here for delivery timeout to control retries. Okay, so we talked a little bit about the delivery timeout before, but I said this puts an upper bound on the time to report success or failure after a call to send. So the producer has a job. Producers say, hey, I can have multiple requests in flight at any given time. It could be 1, 2, 3, 5 in flight, a lot of messages in flight at a given time. And then I want the broker to answer my request, to acknowledge my request, to store the messages. And then I have this delivery timeout that puts this upper bound over this time to report success or failure when I do a call to send. So remember, when I do a send, there's a separate thread that will pull this to be sent over the network. So you go through the process of serialization, partitioning, and batching, right? And then the batching, we'll talk about this coming up, very important concept. So batching and also retries, very important, because you want to be able to retry the message if it fails. So if I say, hi, did you get it? I send you a message. If I get no answer, I want to send it again. So retries are very important to make sure that your message gets delivered. But of course, it only matters if you have your ax set to like 1 or ax set to all, right? Retries doesn't matter when you have ax equals 0, right? If ax equals 0, does not matter at all. So this picture that we see here, we'll go over each one of these a little bit at a time. So let's look at the first 2 that we're talking about here. When you're first talking about tuning for performance, notice it says performance tuning. It's like you can tune for throughput, right? And latency, it's very important. Now let's think about it. Imagine that you have a regular sized car like this. This is a car. And maybe this car holds only 5 passengers. Okay. So if they enter the car and then this is the freeway, so at a given time, my throughput is not very much. I'm taking only 5 passengers at a time. That's my throughput, right? Not that high. It's just average throughput. Okay. But imagine if I get a gigantic bus. Here's a gigantic bus. And this bus can hold like maybe 100 passengers. 100, not that's 1,000. 100 passengers. So now I can increase my throughput, right? So I increase my throughput because at a given time, I can take up to 100 passengers, but we're really talking about messages. So what if you look at this batch size, that means if I increase my batch size, that's like the bus size, I can increase my throughput, how much I can go across the network, how many messages go across the network. And then by the same token, if I have a small sports car right here, soon as one passenger gets in, I take off right away. So my throughput is very low throughput. Only one passenger, but it's super fast. So the latency is very low latency. In other words, super fast, which is a good thing. Low latency is good. And that's the linger millisecond, how much you wait. Because I don't have to wait around. I don't have to linger around. Soon as I get a message, I take off right away. Whereas with this bus, think about it. When you go on a trip, if you've ever taken your kids to Disneyland or you've gone on a company trip or school bus, you have to wait for people to get onto the bus. So that means you have to increase your latency. That's a linger millisecond, how long you wait around. But by increasing this, you can take more passenger. So if I increase my batch size, I typically want to increase how long I wait around, which is linger millisecond, which means that I can get better throughput. But if I want very low latency, then I don't want to wait around at all, which means this linger millisecond should be very small, very low. And my batch size will probably be that I won't wait. I don't care to wait around much at all. Just as soon as one person enters, take off right away. If that makes sense, then the rest of what we talk about, will make sense as well. Just know that linger millisecond and batch size is important. And then the buffer memory is the total amount of memory you're using to hold all of that information that you have in the buffer of the producer, right? Because remember, we do serialization, partitioning, batching, and we hold this thing. This is how much memory is used in buffer for the producer for all those partitions, data across all of those partitions. So this is important. The default size of that is typically 32 megabytes. Okay. Any questions about this so far? So Sharon said, number of in-flight requests is like how many of vehicles you have for transporting passengers, pretty much. Yeah, because you're doing in batches, and this is your batches are now going to be available to be sent. Excellent analogies. Okay. Any questions, guys? Does that make sense? Okay. Remember, x equals at least 1. I'm looking into chat. Shilling, you are a Confluent employee, so I will wait for someone else to verify the act. That's it. Anyone else other than Shilling? Okay. Yeah, we will, after we go over the big picture, we'll talk about buffer memory. There are times that you may want to adjust these properties, and it's very important to understand when, but there's more that we need to look at before you adjust a tune parameters in just about any environment. You want to be more aware of the total system. So there are times where, yes, you may want to increase the buffer memory if I'm dealing with large number of partitions and I want to hold more on the producer side, or then also depend on the broker side. How big is my request queue, or is there any kind of backlog on that end, as far as if I don't have enough, if it's not too large, what's happening? And then the producer has to buffer a little bit more. So we have to look at the whole picture, and I will keep that in mind as we go through the course, because overall, towards the end, we'll come back. So I would say start out with the default, and if you find yourself finding or needing to tune something, then by that time, you'll probably be more comfortable knowing how each property interact with another so that you can make those adjustments. Okay. So let's look at a little bit more over here, like a Kafka producer. Now we get to the code. The code is the easy part, right? Basic Java. So creating properties in Kafka producer objects is just like the Java util properties object, right? You see that this is an example. I instantiate a properties object, right? And you can call it whatever you want. And then I say props.put, and I specify bootstrap servers property. And remember, in your code, have at least two brokers, broker 1, 9092, comma, broker 2, 9092. Put at least two brokers in your code, not one, is better, okay? And then props.put, I specify the key serializer. I'm saying I'm using the default, well, in this one, not default, but string serializer. And then the value serializer. In this case, I'm saying I want to use Avro. We'll talk about Avro a little bit later. And then this is so I'm using the Kafka producer here. I will instantiate the producer record and then go ahead and pass the properties to it. So this is something that's important to understand. And again, basic Java. So what is this saying? I think their value should not have class that, what is it? Sorry, I'm missing something. I think the class value would not have class in the key serializer.
I think the key serializer should not have the string serializer class. I think that the class is something shouldn't be there, I guess. It should be the class name, right?
Yeah, it's the name of the serializer and the name of the Kafka Avro serializer. And I think it's actually, yeah, you can look at this real quick if you guys want to. The actual truth for all of this is actually go to the API. So when you guys are coding, one of the things I do before you guys are done, I'll take you guys to the API to show you how you can find these things so easily. And give me a second. Let me share my screen here so you can see this. And it's really, really, yeah, you don't have to, as you say, like, you know, our documentation, when when we have these people design our courses, you'll see that sometimes they will go ahead and specify these things that will be a little bit confusing, but you have the string serializer and Kafka Avro serializer. In other words, you're using, when we talk about Avro, you'll see how that works, but these are two things that specify, you don't have to put this here. Kafka producer, when you instantiate this, when we talk about Avro, you'll see how that works. In other words, I can use any object here because we'll talk about the specific records in Avro since I'm using an Kafka Avro serializer. I'll be able to create my producer record and then pass the properties to it. And we'll talk about this a little bit later. But this is just trying to show you the example, yeah. And all right. I'll show you guys the key. Good point, and thanks for pointing that out. So, you know, sometimes when you see things all the time, your eyes just, like someone can show me code and sometimes I will fill it out with the right information in my head just because I'm so used to like seeing certain things. And the same thing will happen with you sometimes. So good eye, if you guys catch it, you'll see it. But this is just essentially telling you, this is the serializer we're using. This is using string and Avro. And then we have other kinds that we can use as well. Byte array serializer, integer serializer, long serializer, and then more. And we can customize it. We'll be able to see a lot of this in the API. Okay. So, but for now, let's look at more of the code. This is saying that you can use the helper classes. I really like to use the properties. I don't like to put my properties inline. I typically like to put it in a different file. And so in this case, but this is talking about the producer config. That's a helper class. So instead of doing like what we did here before, where you create your properties, instant properties objects, and you then pass in each one props.put. When you go ahead and use these helper classes, like I said, producer config dot, in the IDE, when I type dot, I'll see a list of all the different types that I can use. So I don't have to memorize this thing. Makes it easy, right? You can see a list of all the different properties when you type the dot, and then you'll see it in your IDE. So these helper classes, producer config, is very powerful. If you're doing consumers, you'll see that there's a consumer config helper class. And when you're doing streams, guess what? It's a streams config helper class. So these helper classes are very useful, right? When you're working to help prevent errors when you're using Kafka. So very, very important. Okay. And you can also use a properties file. That's what I started to talk about first. Instead of putting all the properties inline, like we saw before with the properties object, you can go ahead and specify like a file, and then you can load that. So there's a very useful things that you can do to make your code a lot more presentable. And then in this case, we're just using very simple key and value. So, hey, look, string K is a key, right? And then the value here is my value. Again, very simple, very, very simple way of just showing you. I'm specifying my key value. And then I then have my producer record. I will encapsulate that key value to the record, and then whatever headers I have, everything will be there. And then whoop, send that. So I then say, here's my producer record, and here's my topic. Oops, there we go. Here's my topic, and the key and the value. So again, this is meant to be very simple. And then I say producer.send and send the record. Okay. So this is important to understand, and just know that, yeah, we'll see a lot more of this as you look at the code. But in the API itself, if you were to look at the Kafka Producer API, which is very easy, I'll take you guys for a tour of it, but you'll see that they give you sample code that's very, very simple to follow. And then actually, let me copy and paste this into chat, and you'll see an example of a very simple producer here. I just click on the site, and I don't want to stop my share, but here, this is an example of what it's going to look like. As you can see the code, right? Very, very simple. Sort of like this. Now, this one is with the transactions, right? And we'll talk about transactions a little bit later. It shows you how, when you're using the transactions API. But as you can see, it's very simple, doesn't change much, right? And this example showing later on when we talk about transactions, you'll see that producer init transactions, producer begin transaction. You'll see all that information. So let's go on to this part. Now, more detail now for the developer. For those of you who are not as familiar with Java or programming, don't worry, that will come. You just have to, as you start to get more familiar with it. But asynchronous sending. So by default, we know you guys are developers. So asynchronous is always non-blocking and much better. There's some caveat to it. Of course, you need to know, like things that kind of, how do you say that, pressure you can put on threads when you're using async methods, but that's for a different discussion. But just know that in general, async is better. So when you're doing this send, producer.send, it is not going to wait for the broker respond before returning. This is, again, you have multiple messages you're going to be sending. So returned, now this is a future with the record metadata. Well, and if you're not familiar with Java, just know that future, maybe some of you guys are familiar with promise and other languages, whatever, but future was added in Java as of 1.5. It's a result of an asynchronous computation, right? That's supposed to happen at some point in the future, and you get these results. Some people look at it as like a, yeah, I mean, it's again, not that big of a deal, but it was added in Java as a 1.5, really useful. So returns a future with the record metadata. And then if you want to force the send to block, you can do a .get. But then if you do the .get, it blocks, gets a message. But again, yes, you have to be aware of some performance related issue. There are guarantees that you can get by using .get, but also be familiar with the way it works. And this is, again, a lot of detail that you will be able to read in the API once you start playing with it. For now, just know that the send call is asynchronous, and that's important. So it's not going to block and wait for the broker to respond, because you have those. So it returns immediately, and that's what's related to the question that we talked about before, right? So puts the buffer in the memory, poof, it's gone. And that's why we have the producer going through those process. The producer goes through the serialization, then the partitioning, then the batching. And then there's a whole bunch of, they usually refer to it as binary queues, but we'll talk about this. So let's go on from here. When do producers actually send? It does not just send the data over the network right away, right? You in return immediately, right? So it's added the message to the local buffer, and that's what is done. But there's a separate background thread that will pull that message, right? And later on and send the message over the network. So the producer to send records in batches rather than, so by doing this, the producer can send batches. And so the producer flushes multiple messages to the broker based on what batch configuration properties. In other words, I can set my batch size and my linear millisecond to control this behavior. There's also a method in the API called flush that you can use at any point to manually flush the data, right? So, but just know that this flush, you call it in the producer code, but you will push all that message from the buffer. In other words, some people say queues, but you'll push it out at once. So that is synchronous, right? Just know that flush is not the same as the operating system flushing to disk. So this one is actually a method that you can use, and you don't want to confuse the two. So again, lots of API stuff doesn't help you as much at this point, but it's just important to know that you will want to come and spend some time with this. In the API, it makes it very clear, right? So send, when you say send and you're sending a record, it's the same as saying send and sending a null, right? So instead of having this, to say it's possible that you can use a callback. And this is very important because this is a interface, and in this, it's an interface that has this on completion method. And if you're familiar with Java, in Java, the way we handle multiple inheritance and other things is if you have an interface, right? You implement the interface. You know, most people are familiar with extending from the class, but you implement the interface. And what does that mean? That means, let's say the interface, you have an interface, and the interface has a method called add. So in the interface, you have actually the signature of the method. Let's say add takes into X and Y and returns this, but it will not be defined. In other words, you have just the signature, but you will not have the definition. So when you implement the interface, you have to, it's basically like signing a contract. Then you have to define those methods. So in this case, this callback has one method called on completion, and the on completion says, hey, look, I'm a method. I takes two parameters. One is a record metadata, and the second one is going to be an exception. And I will either get one or the other. The metadata will be null if an error occurs, or the exception will be null if you do not have an error. You get one or the other. So this on completion takes this thing. So if you want to implement this, then you can use a lambda expression, and that's what they show here. So remember, the send takes record and a null, and instead of the null, I want to use the callback, but the callback has, remember the on completion method, so I can implement this as a lambda expression. So remember, lambda expression, I don't need to specify any access modifiers. I don't need to specify return. I just say, yeah, here's what I want. And this whole thing is returning this body here is what I'm getting back. So I say, given the record metadata and the exception, what I want is check if the exception is not equals null, then print the stack, do whatever I want. Otherwise, go ahead. And in this case, it's just getting value and offset. So the whole point is callbacks can be very powerful if you want to find out detail of what happened to a particular message, right? So for situations, and this is in your notes, they say, for situations when an application needs to verify the successful transfer of the individual message, right? Then you have the send method can be configured with the on completion as method as the callback. So in other words, you use this callback, and then the method will return one of two results. So you get the metadata, record metadata, if the message is successful, or you get an exception if there's an error, right? So you don't get back both. And this is something that to keep in mind. So if you take our developer exam, this kind of question is always on there about callback, just to let you know. I mean, I'm not teaching the exam, but I want you to know that this is relatively important. Understand this. So put an asterisk for yourself if you're going to be certified. Like I know all of our solution architects have to be certified. So this also isn't very important to understand. Okay. And then, yes. So typically, yeah. So it's typically, everything is your async. In the API, we do have the ability to do, we'll see a little bit later, but yes, you're doing by default, since the send is returned immediately afterwards, and it's just using this callback to say, look, I want to know what's going on, but it doesn't change the behavior. So it's still async. And then let's look at this part now. Next part, producer, we want to be able to close the producer, right? And when you close, it's very important because you don't want to leave anything open. That's not good practice. So say, if the producer is unable to complete all the requests before the timeout expires, then the method will fail and you unsend an unacknowledged results. But you want to close and you can take some time out to close. So wait until they complete or some timeout expires. So you want to make sure you close the producer. And then now the last part to this, to the REST proxy. So the REST proxy here, let's look at the REST proxy. What does it say? Okay. In Kafka, remember, this is not using the Kafka client. This is saying that you can use any programming language, as long as you can make HTTP calls to this REST proxy, Confluent REST proxy. Again, this is part of the community edition from Confluent. So with this community edition, you do not have to pay to use it. It's free for you to use. Even if you don't want to pay for enterprise, you can still use it. But when you do a post or get, the post would cause the REST proxy to create a producer on your behalf that is now ready to produce data to Kafka. And then a get is basically creating a consumer to retrieve the data from Kafka, right? So the REST proxy, it's very powerful. As a matter of fact, I've ignored this for some time because people will tell you that from a producer perspective, it's about 2/3 the performance of the native client. But remember, the native clients in Kafka are super fast. So if someone says, well, the REST proxy is about 2/3 the performance from the producer perspective, but that's still super fast. And this is giving you the ability to use any programming language to send data to Kafka through this REST proxy. So I say, you know what? Just try it. Try it for whatever you need to do. And if it doesn't meet your needs for whatever load, then you can say at that point, okay, this is something I've overlooked before. And as a matter of fact, right now I'm trying to build a project, it's a personal project, and I'm really I'm starting to look very heavily at the REST proxy. So I think it's something that I would say, definitely give it a shot, learn to use it. The API is great. And so how does this, let's look at a little bit more information about this. You use HTTP to perform actions. Remember, you will send your HTTP to the proxy, then the proxy creates either the producer or consumer on your behalf, right? So it makes it simple to consume or produce messages to Kafka. Consume messages from Kafka or produce messages to Kafka, right? Or you want to look at what's going on in Kafka. I just want to see what's happening in Kafka. Hey, what is the current state of the cluster, right? Or maybe I want to do some administrative tasks and I just want to use this, just send it through the REST proxy. I can do that. So this is some of the really important options or examples, right? And I like this one a lot. It's something I'm looking into right now. You have a front-end application and you're reporting data to Kafka from it, right? And why? Because maybe you don't have a client, native client to use, or maybe it's just easier to do this way. Or maybe you want to ingest messages into stream processing, right? But doesn't support it's not really supported. This it doesn't support Kafka yet. And that one is sort of interesting. Or you want to do administrative actions in Kafka through this REST proxy. Again, very useful ways of doing it. So the documentation is very useful. Documentation is very good. Highly recommended, right? Now, the REST calls are translated to Java Kafka client calls, and it allows virtually any language to access Kafka. Use post to send the data, and then it has JSON, binary, Avro, protobuf, all of these things, different format that is supported. So the REST proxy basically is a nice tool to say try. If people say it's not as fast, yes, it's not as fast compared to the native client, right? But it's still super fast, and I would say give it a try. Producers maybe it's not as 2/3 of performance, and then consumers even slower, but still give it a try. And then this shows you an example now of using Python as a programming language. This is not the Python client. This is just using Python as a programming language to send data to the REST proxy, right? So you have the topic that you want to write to is part of this URL, and you're specifying the HTTP thing to whatever through the REST proxy. Again, that could be a container or VM, virtual machine, or physical, whatever the machine is, but it's running the REST proxy service, RP, I'll say RP. So you want to specify the HTTP, the URL to that. And then the content type, this is very important here. There's a signature. We don't include it here in this course, but when you're looking at API, it will break this down for you. It's very important to recognize the type, like JSON, the version is important. And this stuff is super important. Okay, you want to pay attention to the version number and the type and stuff like that you're doing. And then in this particular case, we're just showing you that you're using, again, Python as a programming language. You don't have to know Python, but I'm just going to say it's creating the key and the value there. And then you will send the messages. You're doing a post. You say, yes, my URL, and yes, the format, my payload, and headers. And then you want to check the return code, right? Always important when you're working with the APIs, REST, especially REST. See whether you get a 200 or 400, whatever error code. But in this case, you're saying if it's not 200, if it's not successful, then go ahead and do something. So the REST proxy is super, I think it's really nice to understand. And like I said, I've overlooked it before, but this is something that I would highly suggest that you play with and get more comfortable with. And then that brings us to this point. But before I start, just know this is a hands-on exercise. This is Visual Studio. We'll talk about using Visual Studio to open up the code. And then you can do the exercises in Java, Python, C#. Those are the choices that you have. And what I'm going to do is, let's see, hold on one second. I want to share something here. Let's see something. Give me just a second. Okay. So Kafka Producer Lab 3, and hopefully you can see this just okay. So in the Lab 3, they said the goal of this lab is to create a simple producer. And the producer application reads a file of latitude and longitude values and then writes the file to the driver position topic, right? So it's going to be writing this to the driver positions. So that's a topic called driver positions. And this lab is really awesome. So you guys are going to be doing something like Google Maps. I mean, not quite, but where the car is driving around the city and is giving off this longitude and latitude, and then you can see it on your web, on the display by this web server, you'll be able to see that. So every driver will have a driver positions topic, and then you'll see step by step and walk you through this process. But notice, see the example here? There's a driver one, that CSV file, right? For each entry in the file, the application writes a Kafka record. So it's writing a Kafka record for every entry in the file. So when the application reaches the end of the file, it loops back to the top. Record is created with the driver ID. So look at this. The driver ID is going to be the key, and the comma separate list of latitude and longitude would be the value. So driver ID is the key, and then latitude, longitude separated by comma is the value. So it gives you an example here. This is what the key is going to be, and the value will be this, latitude, longitude, right? And then if you look at this picture here now, we have the choices here. You can say, look, I want to, right? If I want to do this in Java, I have to CD to this challenge Java producer. Now, if you are not a developer or you have been away from Java for a long time, you want to do this, then you could go to solutions if you want to, instead of going to challenge. If you go to the challenge, you have to write it yourself. Then you just follow the instructions and you add the code. Okay. If you want to do C#, so pick one of these. You don't have to do all three. Pick any one of these, C# or Python. Okay. And then go to the correct directory. Remember, if you're doing solutions, don't go to challenge, go to solutions directory. And then you will have to bring up all the containers in those environments as well, right? So in this case, notice I'm bringing out Zookeeper, the broker, the control center. There's a container called create topics. This will create the necessary topics we need. And then there's a web server container. So if you're wondering where the data is coming from and how this is done, you can look at the YML file that tells you all the details about what's happening, right? So with this in mind, this is going to be the start. And then you guys will then take it from there, where you will then, you see here, this is the picture of what you're going to be doing, right? Whether you're doing Java or Python or C#, here's the Kafka. This is the driver positions topic. And then you will have a web server that is has a Kafka consumer to consume the data from this topic, latitude, longitude, and then position it in the web browser to show you where you are on the map. Okay. So it's a really cool example, and I think it's really nice. Let's see, all of this is straightforward. Let me see if there's anything I need to mention here. Oh, remember, this is how you open up the code editor. You just go to the right directory. When you're in the directory, you do a code dot, and you start that, okay? And then if you're writing the producer from scratch, it will tell you step by step what to do, and you just have to follow along. So the rest of the class is literally your time. We don't have to do anything else today. You have to do all of chapter 3 lab. And just one more, let me just show you one more thing before I go. Or not before I go, but before I stop. So hold on one second. Let me share my screen. Oops, there we go. Okay, share screen. Oops. I just lost it. Hold on just a second. Just give me 1 second, please. It was right in front of me, and then I lost my coming up in just a second. Where is calf drop? What is calf drop? maybe it's a maybe there's someone wrote a personal script in your work, because you can write a script, call it whatever you want, and then call it whatever you want, and as long as it does what you want it to do. Yeah, there's some really interesting kind of solutions that people come up with. And there we go. Okay, my apologies. I must have closed my session, and there we go. Oh, yeah, we go. I got it now. Okay, in this sharing. So I will now share this. Share screen. And do let me know that if you can see my screen just okay. Everybody see this? Okay, excellent. Thank you so much. So you should be able to see my environment. And now I will come over here. Let's do a Control C. So if I'm in this directory, let's say if I CD to the Confluent dev directory and I CD to solution. Again, I'm just saying solution for the people who are new to this. If you're already comfortable, you can do whatever you want. CD to the Java producer directory. And in this directory, if I do a code dot, I say start the Visual Studio editor in this directory. And then once it opens up, I still had it open up here, so it won't open up in the directory like that and close it again. But once you open up the editor, right, you will then be able to navigate from that Java directory here to say go to my source. And on the source, there's the mean, and on the mean, there's the Java producer. You can also look at things like resources. I think that was part of the first lab. So you can look at all these files, look at your Java producer. And this is, since this is in the solution, it already has a solution. But remember, you have to do the first, bring up all the containers first, and then you can look at the code. The code is very, very helpful, very useful. And you can play around with stuff that you see. You'll be able to play around with a lot of different things as you're writing the code. And so very, very helpful. Yeah. And so it's pretty much, you guys are just responsible for finishing this lab. Tomorrow morning, we will start with chapter 4. And that's pretty much it for today. I'm going to mute myself and stay here to answer any questions. And by another 25, 30 minutes, yeah, okay. Confluent Control Center. Yeah, Confluent Control Center. Who's asking about Confluent? I'm sorry. Let's see if I missed a question. If you want to find out a way to visually look at the messages in Kafka, Confluent Control Center is really awesome for that. So it's built in. Of course, you have to have the enterprise. And if you guys are paying for it, definitely, then you want to use Confluent Control Center. It's the way to go. Yep. I mean, there's some other open source tools out there that you can use if you're not using Confluent Platform. But if you already have Confluent Platform, use the Control Center. It is very powerful and get more powerful every day. Good. You'll be able to see the messages, the format of the message, and then there's also commands that you can run on the command line to see the details of the message. But in Confluent Control Center, you'll be able to look at the message as you do in the database. Okay. Awesome. Thank you. Thank you, gang. And you guys will see that we really, first day, I want to make sure everybody can follow. And before this course is done, I would take you guys through like a flow of the API and the source code and everything else. So that means depending on your expertise level of coding and your background, you will know where we get all of our information from as instructors or consultants or architects. I will show you guys all those kind of places. And then from then, it's really up to you. Yeah, Confluent Control Center allows, you'll see that in Confluent Platform, we've actually integrated ways like role-based access control and everything in our platform. So if you're using Confluent Control Center, it's almost like you have the ability to assign different privileges to people. Like if I don't want you to be able to view certain things, I think I now have the ability to do that. And then we'll talk about access control lists a little bit later. But yeah, it's amazing. C3 is called, because there's 3 letters, CCC, so C3. There's 3 letters, Confluent, and then control, and then center. So we just say C3. Yeah. And then Eric is saying, I think the Kafka drop can check payload. I've been looking at messages. Yeah, awesome. Well, Shilin, you are new, but you already seem to be very comfortable with Kafka. So awesome. Welcome. Okay. So I will mute myself, but I'm not going away. So you can let me know if you have any questions as you do the lab. Okay. And since I am in California, it's going to be, yeah. So at 12:30, typically I hang around, but I think I would prefer to come early rather than to hang around afterwards. So tomorrow I will start the session. I will be here like maybe 30 minutes before. I'll just start the session. If you have any questions, just let me know before class. But in another 21 minutes, I will probably end the session. So in the meantime, I'll let you work and stop talking. Okay. Have fun.